Hey guys, today we're going to look at evaluating function notation from graphs and tables. In general, this doesn't require as much actual work on your paper as evaluating functions from equations or composite functions. Mostly it's just going to be identifying the correct places on your table and graph. So when you're finding function values from a table or graph, we have to identify which input or x value that we're considering, along with which output or your y value. Or if we're being technically more correct, which f of x value you're considering. And then we find where they meet. So for example, if I'm going to use this table and I want to find f of -3, I have to find where my input is -3 and where my f of x is my output, where those meet. So those tend to meet at 2. So f of -3 equals 2. Oops. Went back too far. All right, if I was going to do the same thing, f of 8, well, my input is 8, and my output, or excuse me, and f of x, they meet at 4, right? 8 and f of x meet at 4. In this one, it says my f of x is 9, so what would my x value be if my output is 9? So my output is 9, which means my original x value had to be 2. Same thing with this next one. F of x is 0. My output is 0, so that means my input had to have been 20. Okay. All right, go ahead and you can pause and try these ones on your own and then double check it in a second. And now the second's up, so we're going to do the same thing. So this one I'm going to find f of 20. So if I'm looking at my input is 20 and I'm finding the function at 20, so f of 20 would be 0, right? Because I'm finding my input's 20 and f of x, they meet at 0. F of -5 means I'd go to my x value of -5 and see what my function spits out, and that would be 8. When f of x equals 4, well, careful, there are 2 of them here, right? There's one place where f of x equals 4, and then there's another place where f of x equals 4. So I'm actually going to have 2 answers for this one, right? My input could be 8 or 9. Those would be an option to produce 4. All right. And then for our last one here, they said f of x equals -1, so what would your input have to be? Well, here's -1, so that means my input had to have been 0. All right, so that's basically how you use tables, just a lot of matching up which piece you're looking at. Now we're going to look at graphs. So in this graph below, we want to find the following values. And again, you're just basically going to be doing a lot of meeting up of your graph. So our x values, or our inputs, are along your x-axis, and then your outputs or y values are along your y-axis. So f of 6, I go over to 6, and I want to see what my output is, so I have to actually go up to my graph. So if I go over to 6, and then that's where it meets my graph, so my answer is 2. All right. Then if we look at our next one, f of 2, I'm going to go to where 2 is on my x-axis. I'm going to go up to my graph, and so my output or answer would be 4. All right, f of 0, I go to 0, and then I go up to my graph, and I'm actually already at my output, which is 7. And then f of 5, I go to 5 on my input or my x-axis, goes to about right here, which if I'm estimating, and that's kind of what you have to do from a graph, we get about 1.5. Okay. For this last question for this graph, it says, for which values of x is this statement true, that your output always equals 1? So what I tend to like to do is I like to draw a line at my output. So my output is 1. So at what x values does that happen on my graph? So I see one place where my graph hits 1 here, and then one place where my graph hits 1 here. So for the outputs, I would just have to kind of estimate my x value. So I'd say x equals 4 is one option, where my graph actually has an output of 1. And then I'd say at like 9.5-ish would be the other option. Okay. So go ahead and do, oh wait, this is another example with a context, just kidding, we're not going to try it. quite yet. So consider the graph of f of x below. This graph shows the temperature y outside at different times x over a 24-hour period. So that means that your temperature is your output, right? And then your time is your input. So which of the following would find the temperature at 10 hours? So at 10 hours is time, so I know that this means x equals 10. And so then they want to know what the temperature is, what my output is at 10 hours. So on my graph, I'll go to 10 hours, which is right here. I'll go up to my graph, and then I can go over. Oh, but they don't actually want the answer. They just want to know what the notation is. So basically they're saying if x is 10, I want to know my output when x is 10. So I want to know f of 10 for this answer. And we could find that. If you did f of 10, it's about, let's see, that's 35. So I'd say it's about 32-ish. What would it be? Degrees Fahrenheit. Okay. For the next question, it says which of the following would find the temperature when it is 10 degrees. Oh, this is, first of all, I'm noticing a typo. Oh no, that's correct. So which of the following would find the time, excuse me, I just missed that, when the temperature is 10 degrees. So now they're telling us that the temperature is 10 degrees. So what they're saying is our output is 10 degrees and we want to solve for what the time is. Oops. So if we did that, oh, here we go. Temperature is already 10 degrees, so we could use this to solve for the time that that happens at. If we actually did that on your graph, this is where I would just make a line at 10 degrees, and I would figure out the 2 times that that happens at. So it happens once at about, I would say, 4.5 hours, and then it happens another time at 20 hours. Okay. All right, I think we got one more question for this part. Oh, nope. We're going to go straight to the you try now. All right, so if you want to take a pause and try and do that. Okay, and then now that we're done with that, we're going to find all of these pieces of information. All right, so you have a table of g of x and you have a graph of h of x, so make sure you pay attention to which function it's asking you about. So g of -3, so if I go to -3 is my input and g is my function, so g of -3 would be 2. Then for the next one, I'm finding g of 0. So if I go to an input of 0 and where g meets that, my output would also be 0. All right, for my h, that's using my graph, so h of -1 means I'd go to -1 on my x-axis and I'd go up to my graph and then my output would be 1. And then h of 5 would be 1, 2, 3, 4, 5 on my x-axis. I'd go up to my graph, and that output is also 1. Excellent. Now we're going to do a little bit of work. So you can do the same types of things with your function notation. So like this is when you add 2 functions together, this is a composition of functions. This is like a crazy composition of functions, but we can still handle it. So let's go ahead and work on this first one. G of -5 means I'm going to use my table because that's G. So if I do G of -5, well, input's -5, and then G, so 10 is G of -5. Then I'm going to use my graph to find h of -3. So if we go 1, 2, 3, go up to my graph, and so my output is 2. So I get 10 plus 2, which gives me 12. All right, in this next one, so this is a composite function, so we just start working from the inside out. So the first thing I'm going to find is g of -2, and I find that from my table. So I go to an x value, or an input of -2, and then I go to your g, and that's where they meet. So g of -2 is 3, which means I'm just going to replace this with the number 3. So really what I'm finding now is h of 3. And then h of 3 I can find from my graph. 1, 2, 3. And my output would be -1. So my final answer here would be -1. All right, for this last one, it looks tricky, but we're just going to go ahead and start working from the inside out. So you start with the very inside piece first. And I'm actually going to do my work up here because I have a little more space. So the first thing I'm going to find is I'm going to find g of -4. I'm going to go over here. G of -4. So from my table, x value of -4 and then g, where those meet, is 5. So then really what I'm finding next is I'm finding, I'll write it in a different color now, g of h of 5, because I'm replacing that g of -4 with a 5. Okay, so now let's go ahead and work from this inside piece. So h of 5 now would equal 1, 2, 3, 4, 5. My output would be 3. So that means I can replace my h of 5 with a 3. So then now I'll be finding g of h of 3. Okay. And I have, for h of 3, still working from the inside out, h of 3 would be 1, 2, 3. So my output would be -1. So h of 3 would be -1. So now I'm going to replace that with a -1. So now, last but not least, I'm finding g of, -1. So g, and here's x, -1, g of -1 is 1. My final answer. Woohoo! The last one's a little tricky, but perfectly acceptable, right? It's just the same practice, just work from your inside out. All right, if you guys have questions, feel free to ask, or you can also move on, and I have provided a video with many more optional examples and or practice problems, so feel free to utilize that as well. Thanks, guys.